A rotation is a transformation which turns an object around a fixed point, which for 8th grade math is the origin. This fixed point is called the center of rotation. In other words, it is rotated around some sort of fixed point, and that fixed point is called the center of rotation. For our purposes, the center of rotation will be the origin. If you rotate an object around a given point, come in, what information will you need? Who locks the door? That's what I want to know. It's not locked. Yes. Thanks. Ambria, you can pick that up off the table when we're done, okay? For pictures Wednesday, I'm sure. If you rotate an object around a given point, what information will you need? You're going to need two things. One is you're going to need a direction. In other words, you are going to need which way to go. So we have two ways when you rotate around the origin. One way is clockwise, which we will denote by a C. The other way is counterclockwise, which is denoted by a CC. Okay? Now, I know most of you tell me you can't read the clock that's on the wall. Okay? You don't have to read the clock on the wall for this. Do you know which way the minute hand goes or the second hand? Do you guys know which way that goes? How many of you know which way it goes when it ticks? Okay? It goes to the right. That's correct. And that is called clockwise. Okay? Counterclockwise would be going to the left or backwards on the clock. All right? So what we need to know is that clockwise is going to the right. Counterclockwise is going to the left. And I just gave you an arrow in which way it goes. All right? The second thing besides direction that we must have information about is the amount or the degree, which is the distance, how far we are going to go. Okay? And we only have 4 distances in 8th grade that we are able to go, or we will be going. They will be 90 degrees, 180 degrees, 270 degrees, or 360 degrees. So we need to know direction, meaning which way to go, and then we need to know degree, which is how far to go. And when I talk about 90 degrees, 180, 270, how far is it away, all the way around a circle? How many of you know that? 360, correct? So if I start at 12 on my clock, going all the way around would be I'd end up at 12 and I'd be at 360. If I go 180, that's half of that, I would end up at 6. And it doesn't matter if I go clockwise or counterclockwise, I'd still end up at 6 if I started at 12. Do you see that? Now, 90 degrees and 270 are just your 15-minute increments, all right? Each quadrant, if I give you a 4-quadrant grid, is worth 90 degrees. If you move from here to here, it's 2 90s. 190, 290, so that's 180. If you move 3 times, it's 270, because 3 times 9 is 27 plus your 0 for the 0 on the end of 90. Okay? If you move 1 time, it's 90 degrees. If you move all the way around, it's it's 360. It's pretty simple to figure out. After an object is rotated, will the image be congruent or similar to the original? What do you think? What does congruent mean, people? Same shape, same size. That's right. If you notice this P, it is being rotated clockwise around, or you could look at it being rotated counterclockwise. Doesn't the P look about the same size? And it looks like the same shape. What changes is the orientation. And remember, the orientation was how it looks. But that doesn't change the size or the shape. So, after an object is rotated, it is congruent. Same shape. Same size. So what three transformations have we learned about? Name them. Translations, reflections, now rotations. All three maintain congruency. Same shot, same size, same shape. Okay? All right, let's flip this little P around. We're going to go this way, and I'm going to put these arrows on the inside of the P. Because what I'm going to do is say from here to here is 90 degrees clockwise. From here to here is 180 degrees clockwise. From here to here is 270 degrees clockwise. And from here to here is what? So all the way around is going to be 360 degrees clockwise. Okay. Now, what if I was to go from here, and I'm going to do this towards the outside of my P, or in the middle, to there? What way have I moved? So it's, and I've gone one time, haven't I? 90 degrees, counterclockwise. So going 270 clockwise is the same as going 90 counterclockwise. How about from here to here? Now I've gone from here all the way down to here. I'm at 180 degrees counterclockwise. So going from here to here clockwise is the same as going from here to here counterclockwise. You see that? I'm going to go counterclockwise one more time. Now how many degrees am I? 270 degrees counterclockwise. So 90 degrees clockwise is the same as 270 degrees counterclockwise. All right, if I go one more time counterclockwise, where am I at? So I'm going to put that here, and I'm going to go this way around my circle that I'm going to draw this time. And I'm going to say that is equal to 360 degrees counterclockwise. Okay? So 360 degrees is going to be the same whether you go counterclockwise or clockwise. Everybody got all that? Okay, let's flip the page. Triangle ABC is labeled and rotated on the graphs below. Write the coordinates of the images and write the rule for the rotation. We're going to start noting these as the original and the new, okay? Because when we get to scale factor, we need to know those terms because it's a really easy way for us to memorize how to find the scale factor. So, what I need you to do here is I need you to original, which one? The one on the right or the one on the left? The right, because it doesn't have the prime symbol. Remember, the prime symbol means it's the new. So I've got an original and I've got a new. Okay, so I went from here to here. And I wanted, no, we did it. We wrote the coordinate grid, right? Yeah, okay. So I've gone from one and directly to another quadrant. I only moved one quadrant. One quadrant is worth how many degrees? 90. And I'm going what way? Counterclockwise, okay? So a rotation. I started out with A being 1, 4. Now A is at what? -4, 1. So A prime is at -4 and 1. B originally started at 5 and 2. Now B is prime is at -2 and 5. So I've just made a turn. So -2 and 5. Does anybody kind of see a pattern that's happening here? So you're changing your X and Y, aren't you? To be Y and X, and you're changing the sign on that Y. So here I've got 2 and 0, and now I've got 0 and 2. Why don't I put a negative sign on that 0? Because it can't be negative or positive. That's correct. So our rule for every XY pair, the rule for 90 degrees counterclockwise rotation about the order is flip your X and Y pair and change the sign on your Y. Remember, that means change the sign on your Y. Now, 90 degrees counterclockwise, let's look back here. Oh my goodness. 90 degrees counterclockwise is the same as what? So the rule would be the same for 270 degrees clockwise. Do you see how that happens? So instead of going from here to here, I would have gone from here. I would have moved 90 degrees, 180 degrees, 270 degrees. Okay? All right, let's look at the next one. Our original and our new. We're going to go 180 degrees counterclockwise. So counterclockwise means I'm going to the left. I've moved one quadrant. I've moved 2 quadrants. That's 180 degrees. 90 plus 90 is 180 degrees. So I was at 1 and 4. Now where's A? Now A is at what? -1, -4. So -1, -4. B was at 5 and 2. Now B is at -5, -2. C was at 2 and 0. Now C is at -2 and 0. So the rule for 180 degree rotation, counterclockwise or clockwise, is for every X and Y pair, what did we do? So we changed the sign on the X. Please say change the sign. and we changed the sign on the y. Because if I'd gone from here to here, it would have been negative to begin with and would have ended up being what? Positive. Okay? All right? So you leave your x and y pair, you just change the signs on them. All right, next one. I've got an original and I have a new. They're saying 270 degrees counterclockwise. What happened to my A? It was at 1 and 4. Now what is it at? 4, negative 1. B was at 5 and 2. Now where is it? 2, negative 5. C was at 2 and 0. C is now at 0, negative 2. So, for a rule for 270 degrees counterclockwise or 90 degrees clockwise, the rule is what? What did we do here? We flipped them and we changed the sign on which one? The x. See how the x was a positive 1? Now it's a negative 1. So we're going to flip the y and x, and we're going to flip places and change the sign on our x. Okay? All right, so let's do one more thing. So what happens when you rotate a figure 360 degrees clockwise or counterclockwise? What's going to happen to my x and y coordinate pair? Here's my x and y coordinate pair. If I rotate them this way 360 degrees, or I rotate them this way 360 degrees, what happens? Stays the same, don't they? So, what's the rule for every x and y pair? They stay x and y. They stay the same. And I'm going to put a little asterisk there because that's a test question. I'll tell you right now. So what happens here? My A is at 1 and 4. What's my A prime at? 1 and 4. B prime is at 5 and 2. C prime is at 2 and 0. They remain the same. Okay, this right here in these rules should have been 90 degrees. My bad. Okay, so if you will cross that out, I would appreciate it. But we're going to make this a little bit easier to read for you. Okay, and I'll redo this next year. So we're going to take out our note card. And we're going to write rotation rules. Okay? And you're going to write all the way on this side, counterclockwise. And you can do a CC if you want. You can make an arrow going this way and do CC next to it to remind you that that's the way counterclockwise is. If you need that help, go right ahead. Okay? Then on this side, we're going to write clockwise. And I'm going to do the same thing. If you want to do that, you can do this. And you can put a C there. Because sometimes they'll give you the C or CC, and sometimes they'll actually spell out the word. Okay? And then in the middle, you're going to write rules. And you should have enough space to do 90 degrees, 180 degrees, 270 degrees, 360 degrees. In the middle, you're going to write the rule. For a counterclockwise, 90 degrees, well, the rule is change the y, flip the y and x, and change the sign on the y. That is the same for 270 degrees counterclockwise. For 180 degrees, you change the x, the sign on the x, and you change the sign on the y. And that is the same for 180 degrees clockwise. 270 degrees counterclockwise. You flip your y and x and change the sign on x. That is the same as 90 degrees clockwise. For 360 degrees, what did we decide? Everything stays the same. Counterclockwise or clockwise. Okay, so we're going to use our note card and we're going to do a little practice down here. Okay? Everybody ready? Says write the rule, then list the new coordinate point for the rotation given. Coordinate point 3, -2 under a 90-degree counterclockwise rotation about the order. So if I go to counterclockwise, I go 90 degrees. What's my rule? Change, flip your x and y, change the sign on your y. Okay? Then it says write the new coordinate point. If my original point was 3, -2, what am I going to do? Okay, I'm going to change the sign on my y and flip, oh, look at me, flip my x and y value. So I get +2, +3. All right, 180 degrees. What's the rule? Change the sign on the y, change the sign on the x, change the sign on the y. New coordinate point is going to be what? Nope, it doesn't say negative. It says change the sign on the x. What is x right now? -5. So what's x going to be now? +5. I've got a +4. Now what are you going to have? -4. Okay. Coordinate point of 3, 2 under 90-degree clockwise rotation about the origin. So I'm going to go to clockwise on my card. I'm going to look at 90 degrees, and it's going to say what? Flip my y and x and change the sign on what? X. So what's my new point? 2, -3. Okay, last one, 180 degrees. What's the rule? Change the sign on x, change the sign on y. So what is my new point, Jamarian? That's correct. 6 and 4. Okay?